Okay, we got a few more things to talk about with relation to straight lines and linear equations. We say that two lines are parallel if they go the same direction and they never meet. They never get any closer together or further apart. And that means that they have the same slope as each other. So in this picture right here, we're looking at two lines that both have a slope of 1 over 2, 1/2. They have different y-intercepts, but they have the same slope. So they are going in the same direction. They're parallel. And then two lines are perpendicular if they do cross, not just any old way, but at right angles to one another. So if one's going east-west, the other's going north-south. If one's going at some angle, the other's going at some other angle where the angle between them is a right angle, a 90-degree angle. So in that case, their slopes would be opposite reciprocals. Opposite in sign, so if one of them's positive, the other one's negative, but other than that, reciprocals of one another. So in this picture, the orange line has a slope of positive 1 over 2, 1/2, and the blue line has a slope of negative 2 over 1, negative 2. So they are opposite reciprocals. So let's look at some examples. What's the slope of this line? Can you see from the graph? Think about if you go from one point to another, how far do you have to rise and how far do you have to run? Well, let's see what happens if we go from this point here on the y-axis to this point here on the x-axis. We go up 2 and we go over 5 spaces. So the rise over the run would be 2 over 5, and that would be the slope, 2/5. Okay, what would be the slope of a line parallel to this one? Answer, same thing, 2/5. So any other line that's parallel to this would also have a slope of 2 over 5. And what would be the slope of a line perpendicular to this one? So it would be opposite sign. This is positive, so opposite would be negative. And then the reciprocal of 2 over 5 would be 5 over 2. So negative 5/2. Let's try another one of these. What's the slope of this line? Think about, to get from one point on this line to another, how far do you have to rise and how far do you have to run? Well, if we start here and go down here, we're going down 4 spaces. So that's like a rise of negative 4 and then a run of 1. So the slope would be negative 4 over 1, or just negative 4. What would be the slope of a line parallel to this one? Negative 4. What would be the slope of a line perpendicular to this one? Positive 1/4. What's the slope of this line? Notice this is a horizontal line. It just goes right straight across. So for a line like that, what's the slope? 0. What would be the slope of a line parallel to this one? Also 0. And what would be the slope of a line perpendicular to this one? Well, normally we would say take the opposite reciprocal. But you can't take the reciprocal of 0. That would be undefined. The slope would be undefined. A line that's perpendicular to this one would be a line that just goes straight up and down, a vertical line. And vertical lines have undefined slope. Okay, let's finish out this section with an application problem involving linear depreciation. So depreciation is where an item, maybe a car, maybe a copy machine, maybe, well, some item loses value over time. As it gets older and older, it's not as new, it's maybe not in as good a working order, or it becomes more obsolete. So it's worth a certain amount when it's new, and then over time, as it gets older and older, its value is less and less. And linear depreciation means that the amount that the value depreciates by is the same each year. So in this example, we're looking at an item whose original value is $110,000, and then it depreciates linearly over 6 years to a scrap value of $20,000. So that's kind of at the end of 6 years, you get rid of it and get a new thing to replace it. And at that time, what it's considered to be worth, in this example, is $20,000. Write a linear equation giving the value V of the equipment during its 6-year lifetime. So we're trying to relate that value to the age. And we have these two data points. When the age was 0, when it was 0 years old, when it was brand new, its value was $110,000. And then at the end of its useful life, when it's 6 years old, its value is $20,000. So we have those two data points. They're like 2 points on a line, and we need to come up with an equation for that line. So we can start by calculating the slope, y-coordinate minus y-coordinate, over x-coordinate minus x-coordinate. Here that would be 20,000 minus 110,000 over 6 minus 0. So 20,000 minus 110,000 is negative 90,000. It's lost $90,000 worth of value over that 6-year period. So when we divide, negative 90,000 divided by 6 is negative 15,000. That's the slope. And what that means here is that the value goes down by $15,000 per year. So that would be the slope. And actually, we do know the y-intercept, because one of these points has 0 for its x-coordinate. That is the y-intercept, or if we're calling it v, I guess it would be the v-intercept of this line. So the y-intercept is the point where x is 0, and that's your starting value. After 0 years have gone by, what's it worth? So because we know the slope and the number for the y-intercept, we can just right away write an equation using that slope-intercept form. Can you see what that would look like? V equals the slope, negative 15,000 times x, plus 110,000. So if you plug in 0 for x, you get 110,000. If you plug in 6 for x, you get 20,000. And if you plug in any number in between 0 and 6, the equation gives you the value of the item after that many years.